All right. So wanted to do a stream tonight, just on some vocab stuff. First, we gotta check the stream, make sure everything's good. Tonight, you'll see my face. It's not as dark in here yet, because I'm doing it earlier. I'm also cooking some meat again, so I'll be checking on that from time to time. Let's see here. I hope you guys liked the last stream. I do want to shout out some cash apps here, and really do appreciate it. Anything you guys give me, I really do appreciate it. And I just buy cryptocurrencies with it. I'm not gonna lie, I just invest it. So pretty much every extra bit of money I have, I invest. Like I just invest. Sometimes it's not the best thing. So I do want to thank D Stew for $5 and Passion Vault for $5. Passion Vault was, I think it was the Passionate. Yeah, the Passionate was in the last live stream that I had on here with Topaz last weekend, and we were talking about exploring adoption and trying to understand that whole piece. So that was a really good stream. A lot of information in there, and it was something that was liked. So I definitely will be doing more streams like that where I explore more topics like that as well. Okay, sound is good. Thank God, because I was talking. All right. Actually, let me close the door. And I'm doing a stream, okay? Alrighty, so tonight in tonight's Obfuscate stream, I want to talk a little bit more about vocabulary. So I'm not gonna lie, I've already told my boss, who's my good friend, that I've just been looking for jobs, and a lot of jobs, I look for junior developer because I just don't feel that I'm senior yet. But all you have out there is senior level developers. Everybody wants the best, or they want the keystone of their team, the head of their team, and then build a team out underneath that. So, I have applied and have had interviews and stuff like that. So it's like, okay, well, I don't think I'm senior yet, but I don't see too many junior jobs. So it's like, okay, well, how can I game myself up for that? So, I've taken advanced JavaScript courses so I can learn more, also to make the app that I'm working on a daily basis at my day job better as well, and also my own skills better. And that's another reason why I want to do this live stream a little bit earlier, is because I actually want to go ahead and watch some cartoons, and then also go ahead and watch some more instructional videos. I'm taking a really good course. Taking a really good course on udemy.com. And I think I'm going to do a giveaway actually to you guys and just like give a gift card for Udemy. I think I mentioned it last time. I actually have to go through with it. But I'm taking this course, JavaScript, the Advanced Concepts 2021. I think this is a really good course so far, and I'm learning quite a bit of information in there. And there's a couple terms that were brought up. So actually, let's bring up the course here. And I won't play it, of course, out of respect to the instructor and the work that he's done, which is excellent. But continued learning education is very important. So let's learn. What should we learn about? Because again, this is an expansion on what I'm already doing. Oh, give me a second. Let me turn this AC off because there you go. My sunroom has like its own like personal AC unit and everything. The fan is usually good enough, but sometimes it's a little bit hotter. Hotter in here, but it was a little bit today, but sun's kind of going down now. But one thing that was talked about was the call stack and memory heap. So with the call stack, essentially it works in a FILO method. So that's first in, last out. So you have your global execution scope, and that's like essentially all your code within JavaScript is actually is within a larger function. So that's kind of cool. And that's like the global scope. And the global scope has some properties and other things that extend it and stuff like that. But you have that global scope, and with that global scope, you get certain properties. So in Node.js or backend JavaScript, it would be the global variable or the process.env variables and stuff like that. So you have like the process and variable, the process environment, which is pretty much global. Someone probably said that wrong. Process.env is like your entire environment. And then you have your global variable. I believe process.env or global is a subset of the process.env. But you also have your global execution scope. In browsers, that would be the window variable or the window, the window variable. So like window dot base URL or something like that. If you wanted to get the URL for the that you're actually working in, the path or what have you, so you can actually get your URL that's in your address bar. You can actually get that and use it. And use it and parse it and do all types of other stuff, and then write codes based off of that. So like if the URL has this as its base, like /profile / some long URL / this / that, you can actually take that, do a dot split, and then your delimiter character could be the / and then it would split it in an array. So you should know that, hey, the first thing after that, or if you want to look at the first thing after the first slash, it'll be in your index 0. That'll be profile. And it's like if it matches profile or matches some string or what have you, then, or matches some type of condition, then go ahead and run this code on this page. And that's kind of how you like have one monolithic JavaScript file that has a whole bunch of if statements in it. And that may or may not be good. So that you can do things like that because of that window variable, that global. You have your global execution scope, but then you also have your global variable that's available. So then you have your call stack, as I was saying, and it's first in, last out. So first in, again, this is a bit of a review for me, so I'm trying to get all this out. But one thing you do, you have your global scope. Your global scope comes in, that executes whatever function that you're trying to execute. And also it starts to do things like, and this is things that I have to get better with, in terms of how it actually reads your code. You start talking about things like, is Java interpreted or is it compiled? And the answer would be both. It's an interpreted language, but then some things are also compiled as well, depending on the engine that is used. For the most part, it is they use what they call a JIT compiler, so just-in-time compiler or compilation. So for your for loop, it'll actually compile that, run it, get the actual number, get the value that's returned from that for loop, and then put that right back into your code. And then, whatever in the example here, it was the value was 9, and the final execution of that for loop, the value that was incremented up to the value of 9. So it's like, all right, cool, you got it, and it's like boom, it puts it in there for you, and it puts it in there as like a flat variable. It's not like it's dynamic code that's determining this, so on and so forth. All that stuff just gets executed, where necessary. Like if you execute it on page open, it'll execute it. Some stuff will go all onto the JIT compiler just so it can make things a little bit faster. And then some things will actually just be interpreted. The reason why it does that is because it's a web page, right? So a web page, it's not like, again, this is all the explanation from this great course, and we'll get into some other stuff, but I'm trying to understand it and talk about it. You guys are my rubber ducky, if you will. Look up, go on the Coder YouTube channel. She talks about the rubber ducky effect and what that means. But with the, it's probably not the best thing to do. Yeah, it's not bad. What's the point of showing my face if you don't get the right lighting? So with the JIT compiler, or the just-in-time compiler, it will compile certain things for you and then put them as the flat result where possible. Sometimes you do have it where it just keeps running and then that causes a page to have problems or errors out or anything else like that. And it does protect against that, or protect you against that in some cases. But mainly it's about optimization. So when you're looking at, you're loading a page, it's easier to transport text than it is to compile something and then transport the result. So it'll transport whatever it can after it'll transport everything in terms of like the actual JS file. it'll run it through its JavaScript engine. That engine will go ahead and parse it, do hoisting and things like that. It'll do hoisting in terms of variable hoisting and functions, and execute certain functions. And then it'll start to break it apart and say, okay, well, I parsed this file. These variables need, this variable is this value, this variable is undefined. I'm going to run this code over here. Some of these codes that I'm just going to run right now, and some of these codes I'm going to send back to the call stack, or not the call stack, but some of these variables I'm going to send to the callback queue to get compiled and dealt with. And some of these things that, I don't need to run right now, but I know they exist, and I'll run it on, this event or whatever, like an on-click event or something like that. So that's kind of like when I look at this type of stuff and I'm like understanding it a little bit more, it's just like, oh, okay. So if I can write my code in this way, in terms of like the variables that I use, the names that I use, your actual JavaScript engine is written in C, and that JavaScript engine likes patterns, likes things to be the same. So for instance, if you're using like a class or something like that, the way you interact with that class, if you can make it the same, the better. So this course goes into quite a bit of that stuff in terms of like how a page is loaded, the fastest way to handle that page being loaded, and then also getting more into how the page is actually parsed and then delivered to you in a more optimized and fast fashion, and also to the point where your computer doesn't overload or overwork in some cases. But I haven't really gone through a lot of this course. Like, yeah, I'm on this right here. I'm on section 3 out of 17, and so I watch this at work and things like that, or work and some of my downtime and things like that. So I try to get a better understanding of certain things. So the JavaScript engine, I want to discover or read more about the call stack. So as I said, it's first in, last out. So you have your global execution scope that runs all of your code, does all the hoisting and whatever, and parsing your JavaScript files. Once that's done, it starts to say, okay, it pops a function onto the call stack, because now you've defined your variables, defined your functions, and now you said, hey, listen, run this function. It's like, all right, cool. This is the function I'm going to run. It pops it onto the call stack. Within that function, it might call another function or have a routine of some sort, for loop or what have you. So once it's actually in there, then it's going to execute whatever it needs to. Once it's done, then it'll pop it off of the call stack. But the thing is, if that function calls another function, then another function gets popped on top of the call stack. So now you're looking at the global execution scope in terms of that function. And then you're looking at your first function that you called, but then your first function called another function. So we'll just do it like this. Yeah, your global execution scope, your first function, and then your second function. Wow, I almost cursed there, huh? Your second function, it finishes and does what it needs to, and then after that, it comes back to the main function that called it and said, hey, listen, I'm done, return a value, or I'm done returning this value, or I'm done running my process, or I'm done making my API call, or what have you. Now, I don't need you anymore. It'll be like a return or something like that. Miguel, appreciate that, man. Appreciate you always like showing up, bro. I think I want to watch your stream tonight, man. I'm a little bit earlier tonight. I'm a little bit early tonight. You're a moderator, so go ahead and put your link in there. Yeah, for sure. So people go watch Miguel gaming. And Sheed, brother, I always appreciate you always showing up and showing love, man, and showing out. Appreciate you so much, man. And hopefully you're soaking up a little bit of this information too. And, just let people know about what I'm trying to do here, man, because I'm trying to teach people as best as possible, especially our brothers in the space that, know about certain things like this. All right. So once it, that last function that's called, it returns a value or says, hey, listen, I'm done. Then it gets popped off the call stack. Then you have this function. See, I won't even do the middle finger here. So then you have this function here that called this function and says, oh, okay, you're done. There's nothing else for me to do. I get popped off of the call stack. So that's first in, right? And then finally the global execution scope, right? Like, I mean, that's still going to be running because it's running for any event listeners or anything else like that. But first in, it's the last one out, right? Because it called other functions. And so yeah, www.twitchtv.isaz360. And I love his image because he just he looks like some old Spanish poppy or some shit, man. Miguel, bro, I love that image so much, man. That thing is great. That thing is great. Um, so it's the first in, last out. So the global execution scope still runs. It listens for any event listeners, listens for any API calls that were made that still need to come in or still need to finish or anything else like that. So yep, Dale. I always say Dale, but he's just Dale. Dale. So yeah, you have your that's essentially how your call stack works, and then your call stack has memory that is associated with it, and it says, okay, hey, listen, this piece of memory goes for this function or variable, and this is where I'm going to store it. You have that whole heap of memory that you can actually use, and all that stuff gets allocated, or all that stuff gets allocated and handled by usually your JavaScript engine and any of the other tools and browser tools and things like that. So that's where, you might actually have your browser say, hey, listen, you're using up too much memory. You use up more memory than you have. You have certain limitations and things like that. A lot of things are abstracted away from you in a high level language like JavaScript. It's not like C, where C, you actually have to do a lot of your own garbage collection, memory, what's it called? Memory maintenance, if you will, or memory. There's another word I want to use, but you don't have to do as much in terms of controlling what's necessary for your memory, in terms of like garbage collection, in terms of ensuring that loops don't run forever. There's certain things where you have a language that actually acts as your foundation, and doesn't talk directly to the processor. It's not compiled or anything like that, but it's interpreted or it's a JIT compiled. There's some things that you don't have to do that the underlying system, Node.js or the browser does for you, that you don't have to do and you don't have to worry about. So I can write my code and not have to worry about these things unless I have a function that, is a while loop or something like, or a for loop that goes on forever. Again, guys, do your research. Go ahead and buy this course. I just got paid today, so I should go ahead and get some type of. I'll probably do some type of gift card or something like that. I don't know. Yeah, I don't know. For those, okay, how about this? For those that are watching the stream, the first two people to follow the instructions properly, students. The first two people to email me the exact name of this stream and say, I'm here to redeem my gift card, gets a gift card. So it's first two people, and the value will be, we'll say, I think you can afford $20. $20 a piece. Yeah, so $20 a piece. My email is, what do I want my email to be? My email is AOE, the number 4, EVA@gmail.com. It's AOE, the number 4, EVA@gmail.com. And you will get a $20 Udemy gift card. I think I can do this. If I can't do it, then I'll just cash app you $20 and you can get it your damn self. How about that? So we'll just take some of the money that I've been getting in the past, and we'll just give it back out. I do want to do it in the form of a Udemy gift card, Udemy.com gift card, because I want it to be used for educational purposes, and I want you all to further your education. It's very important that you do things outside of your regular day job, just so you can actually sharpen your skills. Guys, I'll be right back. Give me a sec. Okay, I'm back. Yeah, so let's see. I probably got emails already, but I'll check them after the stream. But yeah, for those catching it live and everything like that, definitely want to promote that. Alrighty. So I want to do some more research or extend our research past just what this course has taught me that I may have butchered and gotten some things wrong. Let's talk a little bit more about the call stack. No, I like that article. Oh, wait, let me. StreamYard in. Okay. So I usually like to get documentation a little bit from the source. There are a multitude of JavaScript engines, some, one engine per browser in some cases. One of the more popular ones, quote unquote, the best, is the JavaScript V8 or is the Google V8 engine, and that is actually also at the heart of Node.js. But in terms of better documentation and about the language and things like that, probably one of the better places and easily searchable and has a lot of information about it is MDM or MDN, so the Mozilla Developer Network, or developer.mozilla.org. Let's see what it says about call stack. So we'll just go in and read a couple things about each one of these concepts or vocab word, if you will, and then go from there. Okay. Do you want to? Cool. All right. So increase the font size for you guys. Call stack. A call stack is a mechanism for an interpreter, just like JavaScript interpreter in a web browser. Again, JavaScript is both interpreted and compiled. It just depends on what you actually have. So I usually call it a hybrid language now, especially if you're asked about that. You would be actually correct if you said interpreted, but you'd also be correct if you said compiled, and it's just somewhat compiled. All right. Web browser, to keep track of its place in a script that calls multiple functions. What function is currently being run and what functions are called from within that function, etc. When a script calls a function, the interpreter adds it to the call stack and then starts carrying out the function. Any functions that are called by that function are added to the call stack further up. So that's kind of like what I was saying, the global execution scope, function one calling function two. Added to the call stack further up and run where their calls are reached, or run where their calls are reached. Okay. When the correct function is finished, the interpreter takes it off the stack and resumes execution where it left off in the last code listing. If the stack takes up more space than it had assigned to it, it results in a Stack Overflow error, like your popular website that everybody loves to get all their solutions from, your boy included. So yeah, it made me think about something I did. So in terms of that, that has to deal with your resources, memory, and other things like that, and making sure that you're not using too much resources and you don't actually overload your stack by giving it a ton of different functions to work with. And that's kind of also how you help to optimize your own code to say, hey, listen, I only need to run this. I try to be, quote unquote, as efficient as possible in terms of my code. I don't have a ton of event listeners, but that doesn't really mean that my code is more efficient than something like an Amazon.com website, or Amazon.com page. Because it might have a ton of event listeners that are actually listening out for, maybe it has a heat map event listener. So it's looking at mouse on click and stuff like that. For instance, if I did inspect console mouse event, and just have that run. Native code. Okay. Mouse event. I think I do this. No. Hold on. I want to show you guys. Mouse event. JavaScript. I forgot what it is. On mouse enter. On mouse move. These events. Okay, now there's a properties and methods. Trying to look for an exact. Trying to look for an exact code snippet on this. Button.on click. Okay, cool. So I can do on mouse move, on mouse move, console. All right, let's try to do this here. So we're gonna do a quick on mouse move, and then we'll say something like, what is that? Is that a function? It takes a function, or on mouse down. On mouse and what is it? There we go. Add event listener. I don't do this often because I always do add. I always attach like an event listener. So this is good for me to learn here. So target that event listener. Add event listener. Event target. Okay, so document. I think I could do document. Okay, add event listener. Type. Type will be on mouse move, and then listener. Click and then the function. Okay, cool. So let's just do an arrow function equals, and then I will do. What do I need to do? It's just console.log. Moving. Oh goodness. Document. How about this? You want to do window? Attributes, active element. Okay, so I need to do down window object. Document almost move. Okay. It's not what I was. Function. All right, so document mouse. Okay, and we'll just write a function here, and we'll do an arrow function, and then we'll do an iffy function here. So, and I'll go over that here in a little bit. Iffy stands for immediately invoked function expression. And so I'm just going to do this, and then I'll do console.log. Oh, wow. I don't know why I'm assigning it, but I don't know why it's not calling it, especially with this. All right. I'll figure that out, or I'll have to figure it out another time. Call that a fail. But yeah, sorry. All right, so let's keep on going with the call stack here. I definitely want to get that working. So example, function greeting, some code here, say hi, and then say hi gets called. And then after that, greeting is the function that you're actually calling here. And then once that greeting, it gets called, you do say hi, and then it does say hi, return hi. And then even with the return hi, it just returns it, but where is it returning it to? You might want to do like say hi, and then that actually is wrapped in a console.log or an alert of some sort. So for instance, if we were to even take this here, and let's see if we can get something that's not gonna fail. This one's a pretty simple example. I think it says before it looks bad, maybe. I don't know. We'll see. And hi, and we'll do alert. And this is one thing that's like pretty cool about with JavaScript is even with this alert, you'll see how that is not going to be the greatest thing. So because of what it actually does. So we'll do inspect, and with inspect, you can bring up the console, and then in the console, you can actually go ahead and type in code. So I can type in full functions, and then I can call greeting, and then go from there. And then it'll say hi, right? But the thing is now I can't do anything with the site. I can't even interact with it and copy and paste anything. So that's a bit of an issue there. So it's like, all right, cool. How can you get past something like, or how can you get past something like that? You want to call functions that will push this into a div, or console log this out or something like that. So if I wanted to, I can, let's choose, okay. If I wanted to, I can go back up a little bit, define this function again, or overwrite what I did in a sense, console.log. And then enter that, call greeting again, and then it just console logs out hi and then just returns it. But you can do this as like, targeting a div. So for instance, let's target this div, ahref, permalink to example. So, here we go, example. All right, so what we'll do is we'll call this function again, and instead of that, we'll do, instead of this, we'll say document dot get element by ID. We have the ID. We can also do get element by title, I believe, and then get element by, other things. Like you can even do like query selector is another one that I like to use for the things I don't remember if it actually has a subfunction for it. So, but we can do example, and then we can do dot inner HTML. And then equals, and then we can check. Then we can just assign that to say hi. Say hi, and then go like that. there. Can I enter it? All right, cool. Oh man. All right, I gotta do all that over again. Document. Thank you guys for bearing with me for those that are here. Part of the reason why I do these live coding sessions is to get better myself and then show you some of the things that I've learned and how that could possibly even help you. That'd be great, you know. And do that, and we'll actually run the function. So you'll see that we replaced high. We replaced that element with high. So, you know, that's one of the things that you want to do. So with that, in terms of like how it ran that and what it did on the call stack, it called, you know, the global execution variable. So if I wanted to do console.log, and there's also different consoles if you wanted, like, so console.assert, console.clear, context. The one I like to use is .error. That gives you better text highlighting. So error, and this is like, I use this in my try catch blocks. So my try catch blocks or my dot catches, if you're using the then syntax. If I do error, I could do like error, and then it'll give it that red syntax to it, and then you can do actually console warning or warn, and then it'll give the yellow syntax. So things like that are really good when you're actually trying to debug your front end code, and also when it comes to putting information out, sending information maybe to a backend API or anything like that, kind of like I was talking about before, or in a previous stream. All right, cool. So the code above would be executed like this: ignore all functions until it reaches the greetings function, function invocation. Add the greeting function to the call stack list. That's actually pretty cool. So it's essentially saying that it's ignoring all these functions because it has the function keyword, but it's ignoring these functions because, you know, we don't really need to do anything with them right now. They're also not being invoked earlier or before greeting. Greeting is the first function invocation that we're getting in this actual script. And then execute all lines of code inside greeting function. Get to the say hi function invocation, right? So it's executing all the lines within this. It's executing all the lines within there, and then do say hi, and then say hi. We execute all the stuff within say hi. Add say hi function to the call stack list. So you see how the call stack list, we have a greeting, and then we have say hi. One thing I do want to actually look at too is the console.log. And then I wanted to say window. So if I look at window, so right here, this is essentially like our entire environment. This would be things like, I wouldn't doubt there's things like, you know, what type of browser it is. Yeah, so client information, navigator, product sub, so that's the version, and then vendor, Google Inc. So when you go to websites like ipchicken.com, along with, you know, getting your IP address. Another thing that they do is they actually get a little bit more about your browser, and that information comes from you know, these window variables and some other things that are passed along within this. So if I wanted to see if I could find it, like I think it says gecko. Google. Yeah, so we can get more information about the browser. In terms of this gecko part, I'm not sure how it's actually getting that. I don't know if it's like because it says Mozilla 5.0, Windows NT 10, so Apple WebKit. So I guess these are some of the things, and it says Chrome here, so that gives me that. Safari. I guess these are some of the things that are actually like communicating with it to a certain extent, because I'm not sure what it's calling for. It gives me the remote port. So yeah, okay. I don't fully understand that one, but it would be good to break that down at some point, I guess, or understand like, hey, these things are coming from an object like this, or they're coming from an API call of some sort to its backend to resolve those IP addresses and stuff like that. Another thing is to refer. Is that, do we have that refer? Or? No, that's not. Yeah, that's not it. But yeah, so this is the window variable. This is much like the global execution or the global variable in Node.js. Oh, let's get rid of that. Okay, cool. So that's a little bit more about the call stack. So that, like, I implore you guys to read more about it. I want to move on to the next thing. Actually, let's finish this. Add say hi function to the call stack list. So you can see that greeting is the first one there, and then the last one, or the most recent, is say hi. Execute all lines of code in say hi function until it reaches its end. Return execution to the line that invoked say hi, and continue executing the rest of the greeting function. Delete say hi function from the call stack list, and then greeting is the last thing. When everything inside greeting function has been executed, return to its invoking line to continue executing the rest of the JavaScript code. Delete the greeting function from the call stack list, because we don't have to do anything with it unless it has something like a set interval, set timeout, or something like that. Then it's moved to the callback queue, and then it gets executed from there. So in summary, then you start with an empty call stack. Whenever we invoke a function, it is automatically added to the call stack. Once the function has executed all of its code, it is automatically removed from the call stack. Ultimately, the stack is empty again. Yeah, so that's a little bit more about the call stack. There's more information to it in terms of like getting a little bit deeper into the call stack, and then also getting into things like the callback queue. Actually, let's go ahead and look at the callback queue. We get another JavaScript? No. Learn callback queue. Let's see here. Oh, front end masters. This looks like a pretty good series, and I think I will be taking a course from them as well. Intermediate TypeScript, introduction to Node.js. Oh, okay, cool. Scott Moss works for Netflix. That's really cool. Definitely probably somebody I'll listen to for sure. There is one guy that he goes a little bit more in depth with JavaScript, and I definitely like the little snippet that I heard from him. Darn it. Client-side GraphQL in React. Huh. GraphQL is like the thing nowadays, you know? Oh, Cal Simpson, there you go. And then a little bit about Kyle Simpson. All right, cool. And then getting started with JavaScript. He had a course that I wanted to. Yeah, so Deep JavaScript Foundation V3. I think this was it. So he goes a little bit more into JavaScript, into like what JavaScript is and how it works, and how it actually executes your code, interprets your code, what it interprets, and then it's good to know things like that, because then you could better optimize your code. So and write a better, more performant code, and also get to the point where it's like, okay, I have this code here, and how can I make it, better, or how can I make it to where it doesn't, it catches any and all exceptions, or errors or anything like that. So that's something that's like important, and I'm trying to learn more about. So let's go back here. Let's read a little bit more about the asynchronous callback queue. It's a timeout function. Okay, come on. I'm trying to find something like a more concise definition of what the callback queue is. Callback queue. I really wish it was in Let's see, 33 JavaScript concepts. Number 9, callback queue and event loop. All right, callback queue. This is the data structure. Okay, callback queue. This is the data structure that contains all the callback functions that are ready to be executed. With this basic knowledge, let's go back to our first code example. All right. As soon as the code is executed, console.log.world, it is placed in the call stack. However, console.log.hello is placed in the web APIs since set timeout is the function that the web API supports. So certain functions like set timeout, set interval, even the fetch API, those things are actually supported within the browser. You don't have to bring in like a third-party library. And for me, for instance, I use something like Axios, and with Axios, I have the option to with Axios, I have a little bit of uniformity. I have this library that I use on my front end and my back end, and it's something that I like using in terms of, okay, this is predictable in terms of its behavior, and I understand it a little bit more instead of using Ajax queries for if you're using jQuery, XHR queries if you're using vanilla JavaScript. What else? XHR, and then there's another, and then of course the fetch API, which is very simple. But if you want to get a little bit more control, I like to use Axios, which builds on top of some of the other libraries, or some of the other things that are built into the browser that I just mentioned. So things like set interval and stuff like that, or set timeout, are part of the web API itself or the web browser's API. And then because I set the timer to 0 seconds, it is immediately moved to the callback queue. So with something like set timeout, set interval, it actually gets moved to the callback queue. And then when it moves from the call stack to the callback queue, then the callback queue has to execute that information, meaning that it waits for whatever condition to be reached. So in this case, set timeout is set to 0. So as soon as it gets to the callback queue, it immediately goes back to the call stack and says, hey, this is ready. But it actually has to go through the callback queue and wait there and then come back to the call stack. It's not like the call stack sees it and says, oh, this is 0. No, as soon as it sees it, it goes to the web API. Web API says, hey, go to the callback queue. And then the callback queue says, hey, this is immediate. This timer is done. It's ready. It executes, moves it back to the web API and then to the call stack. Or sorry, from the callback queue to the call stack. All right. So note that the 0 milliseconds second argument for the set timeout function doesn't mean it will be executed after 0 milliseconds, but it means that it will be moved to the callback queue after 0 milliseconds. That's interesting. That's interesting. Let me actually get this article in the chat for you guys. You gotta go back and make sure that these links are like clickable and everything in the chat. So, all right. So even if it was like, you know, one millisecond or something like that, it still has to do all these different moves. So it doesn't get actually invoked immediately. It actually gets invoked over time, or once whatever condition is necessary, or once it's done processing is reached. So if it's like set interval, it'll wait whatever that interval is every couple seconds, what have you, or even set timeout. So the way set timeout works is it gets moved to the web API and then to the callback queue. But with set timeout, it actually waits the first second, so it doesn't immediately become invoked. It actually goes to the background. It goes into the background, waits a second, and then gets invoked. So when you have something where you want it to be invoked immediately, but then you also want it to be invoked over time, like after a second or 10 seconds or something like that, then you're going to have to use something like you're going to have to invoke that function, whatever's in set timeout, and then you'll call set timeout, and then set timeout from that point will do the rest of the heavy lifting and execute it every so often. Sorry, it's my meet again. I'll be right back, guys. Yeah, next stream I won't be cooking. Second time I've done that, but I won't be doing on the next stream. Definitely be mindful of it. I just wanted to kind of have an earlier night tonight. I don't plan on going anywhere. I ain't got no damn money for it, but definitely want to get this done. All right, Miguel is the first one to redeem the or request the gift card. So we got one more. Okay, let's go. All right, cool. Cool. So I'll get that. Yeah, so we'll have one more. So pretty much after the stream, there won't be any what's it called? Won't be any availability for the gift card. So yeah. That's cool. That's cool, man. I want to give back to you guys that are watching and then that are learning the little bit that I have, and learning as I learn as well, because I'm trying to do more than just write the language. I want to understand how the language works a little bit more, because I want to become more proficient with my coding, and and not mess up on something like the examples, like the mouse event examples. Like, why doesn't that work? Like, what am I not doing right, or what have you? So I definitely want to what's it called? Get better at that. Start working with just calling an event listener as opposed to attaching an event listener to something else. Oh, I guess that's how I do it. Wait. Sorry, this just popped in my head here. Console. If I do, let's write this code out here. If I do, we already have the document. So if we do document and then equals add event listener, and then it will ask me what type of event. So on mouse move, and then it should ask me for what it wants to do. I probably some cases you can't do an actual arrow function, so I should be able to, but I'm just going to do function, and it'll be an anonymous function. I won't give it a name or anything like that because it's not required. But I will go do this, and then console.log. Sometimes, it's like you don't remember it immediately. And that might not be the... Yeah. Element by... is it by name? Animals, no, it's get element by ID, class name, tag name. I think it's tag name. So, for instance, I should be able to get like element by the entire. Like I should be able to get like element like by body or something like that. Because you can add like an event listener to like damn near every image or something like that. So get element body. Document.body. Okay, so I think that was document. Actually, let's attack this. I want to understand what am I doing wrong and how do I call this properly. So let's go to the documentation. And in this case, I have my target, the type, and then the listener. So the event target method, or the event target method add event listener sets up a function that will be called whenever the specified event is delivered to the target. Common targets is element, document, window, but the target may be an object that supports events, such as an XML HTTP request, an XHR. This is an XHR request. Add event listener works by adding a function to an object that implements event listener to the list of event listeners for the specified event type on the event target on which it's called. A case-sensitive string representing the event type to listen for. Listener, the object that receives a notification. Okay. An object that implements the event interface when an event of specified type occurs. This must be an object implementing the event listener interface or a JavaScript function. See the event listener callback for details on the callback itself, and then the options. Capture once passive. Okay, use capture. Let's see here. So this is the event handler. So this is what it's going to do. And you can do all this stuff inline. So like, all right, see, look at that. Window, test, add event listener, test. Remove event listener. Okay, so I can attach it straight to the body. So my invocation is incorrect. All right, and then test, null. All right, and then in this case, I could do mouse up, handle mouse up, passive support, and those are my options, and I'm not going to use any of those. Oh, yeah, passive supported. All right, cool. Cool. So this should work. This should work, guys. I'm telling you. I'm telling you. Document.body. Oh man. On mouse move. How about we do? Let's do something we know works, right? So for instance, if I do on click, even that doesn't work. So maybe I'm using the wrong thing here. All right, so let's do let. Oh no, I want to do var. Var document. What's it called? Var body equals. Okay. Document dot body. Right. And then with that, I'll say I wonder why it doesn't do the tag though. Document.body. So if I do the elements, I should have a body. I mean, I could do it on the div ID. Well, let's do it on the div ID real quick. Body get element by ID. It has an ID called root. And then mouse move. Maybe like I'm calling the wrong thing because like you could do the mouse move function, but or mouse move event listener, but maybe there's something else. All right, so yeah, maybe JS get mouse movement, mouse location. want to get to the point where I kind of like know some of this stuff. So document that on mouse move, handle mouse move, function, track mouse position. Oh, that's more than I thought it was. And if we break this down, this is just an empty function. So this is immediately invoked function expression. So essentially, you're going to have your function, which is this is an anonymous function here, and then within an anonymous function, within this if, there's an anonymous function which it's just a function with no name. So it's not like you really can call it later on because it has no name to actually be called. And then from there, you can go ahead and just immediately invoke it, or immediately call it or invoke. So, but you can also actually pass parameters in this as well, and then it should pass into here and can be used. So you can pass other variables and things like that, or even like a JSON object or something like that, So I will give in here. Shall I meet the feet? Yeah, see, it doesn't want me to do it here. I don't know why. That's weird. IESIM. I'll leave it alone. Let's move on to our next thing. I think I put this one in there. Yeah. Let's move on to the lexical environment. And this will be the last one because I'm going to tend to my meat. I'm at the rack of ribs that I have baking. I swear. All right. So with this here, JavaScript tutorial, lexical, here's a list of the best development tutorials. All right, cool. I do like that one. Open a new tab. But all right, cool. The lexical environment is an environment where the identifier variable mapping, here identifiers refers to variable function names or variable/function names, during the execution when declared a variable function. It doesn't matter where we call, it creates a lexical environment for that program. So the way it is explained in the course that I'm taking is that your lexical environment could actually be the entire JavaScript file itself, but it can also just be the function itself as well. So like within that function has its own lexical environment, meaning that certain variables that you call within that lexical environment can be scoped to just that lexical environment. So they're isolated. If you do it on a global syntax or the actual JavaScript file itself or the global scope, then if you use like var keywords or let keywords or anything else like that, usually var and const on your global side, but you can of course use let. That's not a problem or anything like that because it'll actually have that same scope. So it'll be used accordingly, but let is usually used within functions that are within the global scope itself. So any functions that you define. But each function itself has its own lexical environment. We can also refer as a combination of local memory and lexical parent. Local memory is a portion of memory that is designed or designated exclusively to a single unit. So, your call stack is going to have a memory heap. That memory heap is going to be split up, and then certain things will be assigned to certain memory heaps or certain portions of the memory heap. So, for instance, you define a function or you invoke a function, and that will be assigned to the memory heap to be used, call, and then call back from that memory. So that'll be like your local storage, if you will, for whatever happens with that function. And that's pretty much what we're saying there. So memory that is designated exclusively to a single unit. That unit would be your variable name or function name. It may also be described, or it may also describe memory specific to the single function or program. To call a function, if it doesn't find the variable in his scope, it goes to the parent scope, and if it doesn't find it in the parent scope, then it goes to the next parent scope, and so on until it finds the variable. If it isn't fine, what in the world? If it isn't find the variable, or if it doesn't find the variable, I guess this person may be Krishna. Oh, okay. So that's an Indian gentleman. Okay. Yeah, that can be excused. I can understand that. All right. So just to correct this, if it doesn't find the variable, it gives the error name. Is it defined or undefined? Which is where you get that, something is variable is undefined or something like that. Defined. Each child is connected to their parent through references or through reference. Take a look at it. Okay. It's kind of hard. So let's go back to a better written article. All right, so we got a Stack Overflow article. This one I will post in the chat. The other one's a little bit harder to read, but gentleman's from India, or I would assume from India, with the name Krishna. Giving the answer based on what I have learned from the secrets of JavaScript Ninja 2E. Okay, they are different concepts but related. We need to define a related concept, execution context, and its stack to understand. Execution context and execution context stack. Execution context is the internal JavaScript construct to track execution of a function or the global code. The JS engine maintains a stack data structure, execution context stack or call stack, which contains these contexts and the global execution context. Okay, so we talked about the global execution context, where that's the big function that runs all of your function, your code. So it takes all that information in, does whatever it needs to, maybe converts that to bytecode, sends certain things to the JIT compiler, just send stuff to the web browser so that it can be understood, and then go from there. Yeah, I think it's like JIT compiler and then bytecode, I think. Or it's bytecode and then JIT compiler. This is where WebAssembly is supposed to take over for some of that stuff as well. So it's another story that I'm trying to understand a little bit better. All right, and a new execution context is created and pushed to the stack, the call stack in this case, when the execution of a function begins. A particular execution context tracks the pointer where the statement of the corresponding function is being executed. So that would be your, when it says it tracks the pointer, so that's like the pointer to your memory heap, is executed. And the execution context is popped from the stack when the corresponding function's execution is finished, meaning that that's the first in, last out. So it pushes it onto the stack, right? It's kind of like your array. You do a dot push dot pop, and if it pops it off the stack once it's actually done, meaning a remove. Lexical environment. It is the internal JS engine construct that holds identifier variable mappings. Here, identifier refers to the name of variables, functions, and variable is the reference to the actual object, including function type, object, or primitive value. A lexical environment also holds reference to a parent lexical environment. So you can also think of like your lexical environment also has inherited properties where necessary. So it has access to like maybe a variable in the global scope, but the global scope doesn't have direct access to the variable within the newly created lexical environment within the function itself, or the IFI function, or the IFI itself. So immediately invoke function expression. If you look up the word, and this is something that, again, from that great course, lexical, it's like an actual word. That's obviously an actual word, but lexical. All right, cool. So it's good to like get the root word of this, and I think this is a great way that the instructor of the course that I'm in actually did this. Of or relating to words or vocabulary of a language as distinguished from its grammar and construction. What the hell was that? Or relating to the lexicon or lexicography. I don't know if maybe lexicography. Lexicon, yeah. So lexicon, lexicography. Anyways, we'll do that. So essentially, you can look. If I was to break this down and actually translate it to what we do in Java or what is in JavaScript, you can look at your function as the actual language itself, maybe even the local dialect. Within that local dialect or language, then you have all the things within it, your lets, your vars, your consts, whatever, any information or objects that are maybe passed in from the greater, or from outside of it, but now is actually integrated within it as like a parameter. And then those would be like, those would be like the words or the things that are distinct to that function, to that language. And within that language, you have certain things that are going to happen. So those would be all the calls that you have in there, maybe an event listener or some other, an Axios call or a API call, I should say, to generalize it. I don't want the word of the day. Yeah, thanks, maybe later. So maybe an API call or something else like that. So yeah, so an API call or of some sort, and then the response from that API call is what I want to say. The response from that API call. Now that response from the API call is now a part of that lexical environment, right? Because maybe you returned it, or maybe it's an eventable and then you returned it, or maybe it's like some type of ID or something else, some alphanumeric or a bit of data or an image, if you will. So now it's within that lexical environment. And when it's within that lexical environment, then we can actually start using it and doing other things with it. Okay. Okay. Parent. So now for every execution context. All right, let's jump down to scope. I think this is important. Scope. It's the language's agnostic concept to refer to the visibility of variables or functions to the executing code. In JavaScript, a variable or function is visible to the executing code if it is there in the current lexical environment. So that's what I talked about a moment ago in terms of like within the function, it has maybe a let or const or an object or some bit of data that's received from an API call. Now it's within that scope or that lexical environment. And, that was a word that I just didn't put in there. And I think it's great to add that, if you look at your function, that's within its scope. And that's how we usually look at things, but that's really called or considered a lexical environment. If it is there in the current lexical environment or the lexical environment chain of the enclosing function. So functions within a function that call another function, maybe like if we look at our greeting function that the greeting function example that we got from Mozilla Developer Network, then it actually called say hi. And then within say hi, it returned the word or the string hi with an exclamation point. So now that's now also within our lexical environment. So it's like things like that, really cool concepts, or really good to understand in terms of the basic knowledge of how the language works. In case of global code, the chain does not exist. Oh, okay. So if you have your global code, then everything within it, is available to the overall. That global is your lexical environment that's created. But your lexical environment can have other lexical environments. It's like lexicalception, like dreams within dreams, functions within functions, your global execution scope. There's functions within that, then there's functions within that. You have your function that says make API call to the back end, something else like that. I think that's pretty good. Now let's probably define one more thing, and then I got a gift card to buy for our friend Miguel. Stack Overflow. Oh, this was pretty cool. It's just pretty cool how this works. And essentially, this is a really good example about how your code is executed and what gets sent to the call stack, right? Like, so your global execution scope, then that calls functions. What gets sent to web APIs, so things like your set timeout, And then what also from those web APIs will get sent to the callback queue and then back to the call stack. All right, so let's go ahead and save and run. So you got foo, bar, baz, set timeout. That goes to your web API. Print hello, goes to the callback queue. Callback queue sends that to the call stack and then pops it off. So we could do rerun, see how everything goes. So we can see that it calls foo, right? We have our invocation of a variable, or sorry, of a not a variable, but a we have our invocation of a function, right? That function calls bar. That bar function calls baz. That baz function says set timeout 3000, and then after that it says print hello 3000 after 3000 milliseconds, which is 3 seconds, and then print hello console log hello from baz. All right, so let's save and run. Foo, and we'll pause. So now we've gone through foo. Foo calls bar. Bar calls baz. Baz says, hey, set timeout, which is a web API, and set timeout, and then within that set timeout, call print hello after 3000 milliseconds. All right, let's resume. That gets into the web APIs. Once it's in the web APIs, then once it's within this section of the web API, it actually goes through the timer of 3000 seconds and sends that to the callback queue, meaning that this has been processed. Now we're going to send it to the callback queue so that it can actually be popped onto the call stack. This is a better definition or a better understanding of it that I have, because I think I said that incorrectly earlier, right? Like I said, well, I partially said it incorrectly earlier, but more or less it's, or more than saying it incorrectly, I understand it better. So, because the last time I saw this was like when I was at work at my night job. So call stack goes to web APIs, then goes to callback queue. So let's go ahead and resume. 3000 seconds. All right, so I want to resume, pause. So now we have in the callback queue, now it says, now this is almost like another stack, if you will. I won't call it that exactly, but just so you have that, understand the concept, this is something else. This is like now you have your callback queue and there's information in there. Then let's go ahead and resume it. Okay, sorry. It wasn't running for me for a second. Let's rerun that. Foo bar baz. So now we see that all these things are finished executing, right? It sent it. It did. Baz already sent. Baz sent the set timeout to the web APIs so it can be executed. Web APIs is going to handle that. You can almost think about it like this. You can think of this even with the event loop concept that you see with Node.js and how it's a single-threaded operation. But with that single-threaded operation, it works in an asynchronous nature. This is how it works in that asynchronous nature. While things are getting popped off of the call stack, things are still happening in the background in the web APIs, and then that'll be pushed to the callback queue. And then once it's pushed to the callback queue, then it ends. Then it gets right back into that the main event loop. So let's resume. Print hello. So now we see, this is why I got messed up, because I actually waited before it actually, okay, this right here is the event loop, or a representation of the event loop, because the event loop, it goes around, right? And then it says, hey, do you have anything in a callback queue? Oh yeah, I do. All right, cool. Let me go ahead and take that and then pop that onto the call stack. Now in that call stack, it might even say, hey, do another set timeout, and then it set times out. It does another set timeout again, or it might be set interval. So it adds certain things to it as well. So let's resume. So console log hello from Baz. All right, does what it needs to do in terms of hello from Baz, and then it goes from there. Like, it doesn't show us anything, but, or actually, it should show us this. So hello from Baz, so we can see here. So hello from Baz, and we can see that it's been done twice because we ran through it twice. So it actually ran that code for us. We just had to have this in here. All right, guys. I'll leave it there. There's some other work that I want to do, but again, the timer's going off for the meet there, so I'll go ahead and check that. I won't be doing that in the next stream. I apologize for that, but I think this is it's a good stopping point. My mouth is getting a little bit dry on it as well. So JavaScript runtime, JavaScript playground, copy link address. Jeez. I'll put this link. It's kind of like crazy, but Jesus, I don't even know. Can you even do that? I don't even think. Jesus, that's close this dialog. All right, I think I can do this because that's like that whole string there. All right, perfect. There we go. I should block myself. There we go. All right, that's the link to get to this tool or this this great example here, where you can get a little bit more information about how all this works or get a visual of it. All righty, guys. Thank you so much for listening. Thank you so much for joining. As I always say, hey, listen, if you're not taking what I say with a grain of salt, you're low on sodium. And as you can see, there's a lot of stuff I don't know and I'm trying to understand and get better at. So definitely, you guys want to sprinkle a little salt on your education there. For the one extra slot that I have, I don't think there's anybody else. Yeah, Miguel's the only one so far. So essentially what I need is you can send an email to aoe4eva@gmail.com. And in that, I need you to put in the title of this stream. Just copy and paste that into the body of the email, and I'll know what it means. So there's one more slot for that in terms of getting a $20 gift card to udemy.com. And if I can't get the gift card, because I haven't looked at this, if I can't get the gift card, then I'll just send you CashApp, or I send you $20 in cash. I guess you can use that for whatever you want, but I would like you to use it for education. So I'm going to try and make this work. That's the best way I can do it without, like, giving my credit card or something like that. And that would be safe. All righty. As always, guys, thank you so much for listening. And I hope you're doing more to learn and improve yourself and sharpen your skills. All right. Peace. Good night.